Okay, so here's number 24 for 10b and 20, I believe, for 12b. So there's a frog hops along the number line from the given rule. So it's not at 0. And then if it is at 0, it moves to 1 with the probability of 1/2. So you're moving right one half probability. It disappears with the 1/2 probability. And for n equals 1, 2, or 3, and if it is at n, which is like at 1 or 2 or 3, it moves to the one higher number with the probability of 1/4 and move to the one lower number with the probability of 1/4 as well. And it is going to disappear again with 1/2 probability. Okay, so with that is given, so we are looking for the probability that it will be the frog will be reaching to 4. This is classic like the states problem, so you can write the recursion equation, I guess, to do so. So, but let's kind of define our like probability. I'm going to call, let's say, P of n is the probability that the frog is eventually reaches like 4, starting from from n. So the n could be 0, 1, 2, or 3. So with that, so we are going to say like P of 4 is immediately 1, because when you are at 4, then you are done, right? So, but with that in mind, so we are looking for P of like 0. So what is the probability of getting from 0 to 4? That's the goal. So like, then we can just start writing the equation. The first thing I will say, P of like 0. So when we are at 0, there's a 1/2 probability that we can move to the 1/2 probability we just disappear. So which is why I'm going to say 1/2 times P of P1, right? So then for the other numbers like 1, 2, or 3, so we can just say like P1, there's like 1/4 probability we can move to the next one, 1/2 probability we can move to the previous one. So which is basically 1/4 of P0 plus P2. So I guess I can write as over 4. In this case, I just write it for as a like common fraction, but since the probabilities are the same, so if this wasn't the case, I would just write this separately. So that should be okay as well. And with that in mind, so I can write that P2 is equal to just the 1 over 4 times P1 plus P3, and then P3 is equal to 1/4 times P2 plus P4. Okay, so then we can start kind of making the relation, find the relation between those P1s, P2s, and Pns, like P4s. And since we know the P4 is like 1, we can just replace that as 1 immediately. And then we want to get the P0. So how do we do that? So maybe we can take this P3 and plug right here to get P2 in terms of P1 and P2. Let's do that. So the P2 is equal to 1/4. Maybe I should multiply all these like by 4, but I'm gonna just leave it as it is. So 1/4 times P1 plus P3. So P1 plus P3. So P3 is like these two. So P2 over 4 plus 1/4 times 1, which is like 1/4. And if I clean this a bit, so that should be like P1 over 4. And then P2 over 4 times 1/4. So that should be like P2 over 16. And then 1/4 times 1/4 will be 1 over 16. So we may combine the P2s, like this is 1 over 16, this is 1. So 1 minus 1 over 16 will be 15 over 16. P2 is equal to P1 over P4 plus 1 over 16. And I can multiply everything by 16, so that should be like 15 P2 is equal to 4 P1 plus 1. Okay, so then I do have P2. Maybe I can write this P2 right here, P2. Maybe I can find the P2 along here. So if you multiply this by 4, so that will give us 4 times P1. That is like 4 equals P0 plus P2. And then P2 is going to be 4 times P1 minus P0. So I'm going to replace right here. So that should be 15 times P2. So which is 4 P1 minus P0 is equal to 4 P1 plus 1. Okay, so then if I multiply, you got 60 P1, and then there's minus 4, so which is going to be 56 P1. And that will be like 15 times P0, which I'm going to put on the side. So you get 15 P0 plus 1. Okay, so now I'm going to plug this P1 into the right here. So P1 is equal to 2 times P0. So that means this equation will be 56 times P1, which is going to be 2 times P0 is equal to 15 times P0 and plus 1. When you multiply these two, so you get like 112, right? So 112 and then minus 15. So subtract 12 from both sides. So you got 3 more. So in that case, we got 97. So 97 times P0 is equal to 1. So P0 is 1 over 97, which is what we are looking for. Yeah, it wasn't like too bad, to be honest, as long as you know how to write the equation using the relation between those H moves, then the rest is kind of algebraic work, which is not too bad, so especially for number 24.